So we're going to do v of 20, minus v of 12 over 20 minus 12. And so that will equal 240 minus 200 all over 20 minus 12. And we can simplify that further to 40 divided by 8, which we all know is 5. And to get our correct units, it's in meters per minute, and since it's v prime of t, it's meters per minute squared. And so that is our answer for number A, or letter A, and that is her average value, or the estimate of v prime of 16. And so next, alright, so now we're going to do part B, and in part B it says, using correct units, explain the meaning of the definite integral from 0 to 40, the absolute value of v of t dt, in the context of the problem. Approximate the value of this integral using a right-Riemann sum with the four subintervals indicated in the table. Alright, so to explain this integral from 0 to 40 vt dt in the absolute value, we should look at what's happening in the problem. And it says Johanna jogs along a straight path, and we're given her velocity and in meters per minute and her time. So her v of t is her velocity. So this integral, and in meters, is the distance that Johanna is jogging. The distance. Let me write this down. Johanna jogs in meters. And we see our time here. It goes from t equals 0 to t equals 40. From time 0 to 40 minutes. Okay, and for our next part of the problem, it asks us to approximate the value of this integral using a right-Riemann sum. And so to do that, we know from our integral right here, and we're using a right-Riemann sum, so v of t dt. And so to do the right-Riemann sum, you do your time, so for example from 12 to 0, and then the velocity of the right side, so this is the right, and then the velocity of the 12. And so that approximation is 12 minus 0, times the absolute value of the velocity of 12. And we're just going to add that to each for our 4 subintervals. And then 20 minus 12 is 8, plus 8 times our velocity of 20, plus 24 minus 20 is 4, times our velocity of 24, finally plus 40 minus 24 is 16, times the velocity of 40. Alright, and so now simplifying that out, we get 12 times 200, plus 8 times 240, which was our velocity of 20, plus 4 times positive 220, since it's an absolute value, and finally add 16 times 150. To further simplify that, we get 2400 plus 1920 plus 880 plus 2400, and finally that simplifies all out to 7,600 meters, which is our approximation of the value from 12 to 20, 20 to 12, 24 to 20, and then 40 to 24. And then multiply it by the velocity of the right side. And so that will approximate to 12. 12 minus 0 is 12 times our absolute value of our velocity of 12. So times v of 12. And we're just going to keep adding it. And then 20 minus 12 equals 8. So 8 times our absolute value of our v of 20, not velocity, sorry. And add that to 24 minus 20, which is 4 times our velocity of 24. And then finally squeeze this in at the end here. 40 minus 24 is 16 times our velocity of 40. So now we can simplify that to equal 12 times our velocity of 12 is 200. Plus 8 times our velocity of 20, which is 240. We're going to add that to 4 times our velocity of 24, and since it's absolute value, it will be positive, not negative. So 220. Finally, and then add 16 times our velocity of 40, which is 150. Simplifying that further, we see that comes out to 2400 plus 1920 plus 880 plus 2400, and that will finally equal 7,600 meters, which is our value for our right-Riemann sum of our integral. And so next, alright, now for part C, we're introduced to something new. It says Bob is riding his bicycle along the same path, and for time 0 to 10, Bob's velocity is modeled by this function b of t equals t cubed minus 6t squared plus 300, where t is measured in minutes and b of t is measured in meters per minute. So now we need to find Bob's acceleration at time t equals 5. And so we know from here that since it's in meters per minute, that is our velocity. And to find the acceleration, we just have to find the derivative of the velocity. So b of t equals t cubed minus 6t squared plus 300. Now we're going to find the derivative of that. B prime of t equals 3t squared minus 12t, and that will just be canceled out to 0. And it's asking us to find his acceleration when your time is equal to 5. So now we're going to substitute 5 in. B of 5 equals 3 times 5 squared minus 12 times 5. So 3 times 25 is 75 minus 12 times 5 is 60. And that will ultimately equal 15 meters per minute squared, which is Bob's acceleration. And finally, for our last part, part D, it says, based on the model B from part C that we just did, find Bob's average velocity during the interval 0 to 10. So to find the average velocity, we are going to integrate our formula and multiply it by 1 over our interval 0 to 10. So right here, 0 to 10 over b minus a, so 1 over 10 minus 0. And we're going to integrate